Hey everyone, welcome back to my shop. I appreciate all the new subscribers that I have, and I appreciate the comments that have been coming through. It's been a while. I apologize, it's been a little while since I've made a video. It's not that I haven't been out here in the shop working. I've had a lot of things going on, but some have been pretty mundane and just general repair type stuff, nothing really of any interest. So I've done this before on several hitches, but I figured I'd demonstrate that on a video and demonstrate this. It's quite common to have the holes in the in ball mounts and receiver tubing elongate over time. So you see I've got a little bit of play in that one. It's not a ton. I've seen worse, but it's enough to where when I'm towing my Jeep and I'm starting and stopping or letting off the accelerator and back on, I can just kind of feel it a little bit. So it's enough that it's bugging me. What I've done in the past on these, a lot of people will just say, you know, just build a new one or replace it or whatever, and that's a very, very viable option. If you have to take this out and pay somebody to do it, may or may not be cost effective, so purchasing a new one would probably be more economic. However, there is a better solution, and basically it spreads the load of the pin over a wider area. Granted, you still have the wall thickness of the tubing, but it seems to add by the time you add the fillet weld and the shaft, it actually lasts longer than just the tubing itself. This is quarter wall tubing, just receiver tubing. Yep, quarter wall. So I've done two different kinds of repairs here. I usually use some higher carbon steel, like this is 8620, I believe. I've used in the past. I've actually used some hardened shafts that I picked up at like a lot sale off of eBay or something. They're a little tougher to machine, but they actually hold up real well. Anyway, for the ones on the internal, the male part, on those what I do is I actually will chuck this up in the mill, bore the hole a little larger, machine the shaft down to accept and drill to go through 5/8 to accept the hitch pin, bevel the outside, cut it at 2 inches because that's what the width of these are. Actually, I think they're just, yeah, they're pretty much right at 2 inches. So I'll cut it, bevel it, and then chamfer the edge here, press the now sleeve of what, if you will, press it in so it's flush, and then weld around the perimeter. For welding, especially when you're using when I use the hardened shafts or the higher carbon content, I usually like to use a 309 stainless rod. 308 will work. They're good for dissimilar compositions. And the thing I like about them is they have a little more elongation in them than, like, you say, a 70S, ER70S2 or an 80S2 or something like that. So what happens is as that's bouncing around, moving around in there, it just seems to give a little bit more, if you will, take the shock, I guess you could say, without fatigue cracking that weld. Now on the other side, on the female side, I've actually done the same thing, but I've bored this out. Come in and find your center, bore it out, and I machine little reducers that actually have a step in them, and I press those in. And you have to be careful, you can't go too long. If you're using a longer, like an implement pin or something like that, you're okay. But if you're just using the regular hitch pin, you have to be careful, because if you go too long, it actually won't fit in there. So, but what that does is it allows you to go, I'm usually about 3/16 thicker than, so you're the quarter wall, and then it sticks out about 3/16 on each side. So it does give you more meat on the receiver part, the female side, but on the stinger part, the male, is where I just put a sleeve through it. Again, there maybe some controversy over doing this as far as cost, but I've actually done quite a few. I've probably done maybe 8 or 10 of these. I've actually done the receivers on some motorhomes where they've got the hitches that are all built up underneath the coaches. You know, they're quite elaborate, mounting up underneath some of these chassis and so forth. And it's definitely cost effective on those to machine the spacers, press them in, and put a nice weld fillet around those. On a ball mount, it's questionable. You might be able to just say, bag it, I'll replace it. This is a custom one I had to build in order to go from my hitch height on my coach up to the tow bar height where it would sit level with my Jeep. So I'm going to take the time to repair this one. I've had this for about 9 years now, probably close to 60,000 miles, and it's just barely getting that little bit of slop in it. So if I go through and machine this sleeve and press it in there and weld it and fix this, I'm good for at least that, if not more. So I'll go ahead and check this up probably in the mill vise first, and go ahead and clean up my elongated hole and figure out what I'm going to need as far as diameter, and then I'll go ahead and machine the sleeve itself. So I'll stop here and move over to the mill. So I'm going to come down, bring my quill down, actually going to find center of the hole. This is where it's elongated, it's kind of a guesstimate, but then I'll come down in with an end mill and open it up so it's nice and perfectly centered in the tube this direction. This way can be off just a little bit, but I'd like to find the center I'd like to get as close to center in the hole as possible. So I will feed it back. I'm watching my DRO, kiss the inside of the first head. So you know what, I'm going to do center top to bottom first. Find center. Okay, zero my Y, and come back the other direction. Now, just hit half of Y, and it'll tell me you gotta go 1 inch 100 thousandths, which is the reason. Okay, there's the center of the hole that way. Now I'll come in and do my x-axis. X. And half X. There's center of my hole. 0, 0. Okay, so now I'll switch out to an end mill and come in and open this up and see what cleans it up, and then I know what size to measure or what to machine the sleeve for. Alright, for starters I'm going to come in here with a 7/8 end mill. So I'm going to calculate my speed here. So 100 surface feet per minute times 4 divided by 0.75. Yeah, 500-ish. I'm just going to sit, I'm staying high here. I'll just leave it there at 600 feet it slightly. So, come down in. I'm actually going to lock my both my X. Lock my X and my Y just so I don't get any chatter in the lead screw. shavings out of there rather than slice the finger open. All right, so now that should be yep, 877-ish. So now I will see, I got a 1-inch shaft there. I may just take it out to 1 inch, and that'll give me more meat around here, more meat for the 5/8 hole, and less machining actually. So I may just do that. Let me see if I got a 1-inch end mill here. Okay, so I do have a 1-inch end mill. If I leave this at 7/8 from the 5/8 hitch pin, that's 1/4 of an inch. That's only going to give me an 1/8 inch wall thickness on the sleeve, which isn't bad. I'd like to get a little thicker, so I'd like to utilize the full 1 inch. Here's my concern: if I go down there with a 1-inch end mill and I've got 1-inch stock, I want to press this sleeve in, have it be an interference fit. So I want to stay 1 to 2 thousandths under that 1-inch mark, which I'm not going to be able to do with that end mill. So I think what I'm going to do is I'm going to set up, just put my boring head in here and come down in here and bore this out to 995 thousandths, 97 thousandths I think it is, because I think that shaft measures just a thou or so under 1 inch. So that way I've got a nice interference fit. Once I get it on machine, I get the 5/8 hole bored or drilled through it, and the hitch pin fits good, nice fitment there. Then I can press it in here, TIG weld around it, and that's done. So that way it uses the interference fit as well as the weld fillet to hold it into this tube. So I think that's what I'm going to do. I'm going to set up my boring. I'm actually going to set up my boring head in here rather than use an end mill. An end mill will be faster, but like I said, I'd like to have that interference fit there. So I'm just going to set up the boring head. I'll go ahead and set this up off camera and then come back in. So rather than rely on my calipers, I'm going to grab my micrometer and just double check. It's possible my calipers are reading a thou or so off. So micrometer says 1 inch right on the money. So I'm going to take this out to probably 998 thousandths, give you a nice interference press fit, and then I'll check up in the lathe and bore the hole in the sleeve after this. Okay, start here at the basic setting. Actually engage the down feed before I engage the down feed. I've got it set on 3 thousandths per revolution, so should make for a nice light cut, nice finish. Finish there. Let me double check, get me a starting point here with a snap gauge. 45. So what is that? 53 thousandths. You want to go? Yep, 53 thousandths. So I'll go at 40. Sitting. Reach in there with a chip removing tool, get the filings out of there. And take another measurement. Should be around 980 something. So. That is 975, right on the money. We're going at 23 thousandths. And that should do it. And I just have to go and put chamfer on each side. And ready to machine the shaft. Or the sleeve rather. All right, I'm about 1.5 thou under. We're right there. Okay, that's good on that. Now let's go ahead and put a chamfer on each side, machine the sleeve, press it in there, and it's ready to rock and roll. This one's ready to rock and roll. Then I have to go in and do this other one. Okay, so I've got my piece of 1 inch chucked up there in the 5C collet and faced it off. So I'm going to come in now and just center drill it. Oops. Creep up on it. I have to move the camera here. Let's go. Knock the edge off of it. So I can face it off right to size. push it, the material coming out, and plug it up and snap a bit off. So clean it out. We got to be close. It felt like it right there. Yep. And there we went through. Sneak up on it. Nice and smooth. Okay, put a chamfer on each side of that and cut it to length, or face it to length rather. So I'm just going to come in here and kiss it with a chamfer on the inside ever so slightly. Actually, I'm going to go just a slightly more. Actually, I'm going to use my faceted cutter. Bingo. Now, going to come in and put a chamfer on the outside edge here so that I can weld, create a weld down in there. About 90 thousandths, that'll work. Okay, now turn around and do the same thing to the other side. Alright, so I took it out, measured it, flip it around. I'll put her back in the collet. And it measures 2" 80 thousandths. So basically I need to take 80 thousandths off of that face. So to do that, I will come in, touch off on my tool, and I'm going to set my dial indicator here up against the carriage, and I'm going to offset it 80 thousandths. Or I'll take that back. I'm going to set it at 20 thousandths so that when I come in I'll be on 0. And that should be right in the money. Come in here and take some facing cuts at about 25–30 thousandths each. Deep cuts. Okay, there's my sleeve. I did have to go in with a boring bar. The farm implement hitches are just a thousandth or two under 5/8. And the regular hitch pin, I use a locking hitch pin, but the regular hitch pins are just a couple thousandths over, more than likely because of the chrome plating. So I had to take just a small boring bar, go in and clean this up. I think I took it out to 635 thousandths, so about 10 thousandths over. And I've got about a 1.5 thou interference fit, so I'm going to take this over the press this in flush, give it a wipe down with some acetone, and weld it. And then I'll come back and start working on the bushings for the other end. And I got to make one more of these for another hitch that I'm doing. So I might as well knock another one of these out while I've got all the tools out. So let's go over the press. Okay, well, no big deal to see these pressed in. If you've seen one bushing or sleeve pressed in, you've seen them all. But I just got my nice newly machined arbor plates, so I wanted to kind of show them off here. So now's as good a time as any, so let's set that in place and press away. Nice interference fit so far. Going nice and smooth. And when my nicely machined arbor plates are freaking awesome. Okay, that should be done. and flush, and flush. So there it is, pressed in. Now I'll run a bead around that on each side with some 309 stainless with TIG, and then I'll move up to the other side over the welding bench. Okay, so I've got my sleeve pressed in there. I've got a chamfer on the sleeve, and I put a small chamfer around the hole in the tube. I didn't want to go in too much because I didn't want to take material away. I just wanted to create a valley in there to put a weld fillet in. Again, I'm using 309 stainless for this. So I've got the machine set. Let's go ahead and run a weld on it, and then it can be cooling while I machine the parts, finish machining the parts for the other end. Should be nice and flush. I may have to breathe over it. The weld is actually sitting down in there quite nicely. I may have to just breathe over it with a welder, or excuse me, with a grinder to knock a couple of ridges off. But I'm trying to keep it down inside that that V. And so far, it's looking like it's doing pretty good. There we go. There's a close-up of it. Let me flip it over. There's a close-up to the other side. So once it cools, I'll go ahead and actually I may probably do a test fit before I grind anything. As long as it fits in the receiver, they look pretty flush. There's a couple of small high spots there and there. If it fits in the receiver tube, good. I probably will leave it. Otherwise, I may just breathe across it with the disc sander or something. Okay, now I'm going to go machine the bushings for this. This in here, I think I'm going to take these out to like 7/8, and then I'll leave the 1 inch, so I'll have a step in it. It'll be a 1/4 inch step that'll go inside, and then I'll just weld a fillet around the outside edge there. So back over to the lathe to finish up those bushings, or reducers. Alright, so due to the thickness, the distance of this, the offset from the outer ring, the offset of the receiver tube to the actual stinger tube, it didn't seem practical to try to grab that in the vise, so I didn't even try. I just brought it up here on some 1-2-3 blocks and set everything on this surface. And I went in and just made sure it was parallel with the table. Then I come in off the front edge here and the back edge, found my center, and off the back end of the hole, the front end of the hole, and found my center. So I'm back to the same thing. I got my 7/8 end mill in there. I'm going to go through 7/8 on both sides. Then the reducer bushings will be 7/8, and then they'll step out to 1 inch, and that's where I'll weld around that perimeter. So it'll step from 1 inch down to 7/8 and be pressed in there. So 1/4 inch of it will be 7/8, and I'm going to stick out whatever I can. It seems like it's about 3/16 of an inch is what I can usually go with a standard hitch pin. If you want to use the implement ones, you can go longer, but I try to keep it standard just in case you ever get in a situation where you're out and about, lose a hitch pin, something comes up. You can go to any auto parts store and get a standard hitch pin and fit in there rather than having to try to find a longer one or a bolt or whatever. So that's why I just try to stay with the standard size. Okay, let's go ahead and mill these out, bore these out to 7/8. Come in and just kissed it. It looks like it's a nice even ring all the way around, so it tells me my distance is, I'm pretty well centered up there. You want to make sure you leave an up end mill sticking out, that you don't bottom it out against the collet before you actually go through. And boom, and through there. Yeah, I made sure I had plenty of distance here to go through that. So, okay, now that that's done, now I can actually go ahead with my go in and clean that up a little bit and make sure. Actually, I don't need to bore this one out because I'm just going to leave it at that. Now I'll measure the hole and I'll machine the reducers to fit that hole rather than try to make the hole fit the reducer or the reducers. Okay, so I got my 2 spacers done. I'll go over and press these in and then come back and put the pin in, and then these are ready to wipe down with acetone. Actually, I'll wipe them down with acetone. I'll wipe that down real quick right now. Give everything a good wiping, and then go over, press these in, and be back at the welding table. So basically this will sit out here like this, pin will go through it, then it'll go through the other one on the other side of the tube and be able to put my lock on. So it ended up being 1/4 inch for the wall thickness, and then 3/16 is what it sticks out. So what is that? Ends up being about 400 and, so is that 7/16? Yep, that's 7/16, 437-ish. So that gives a lot more surface area for that pin to ride on than just a 1/4 inch. So I did a couple of motorhomes by putting these hardened sleeves on. They've worked great, mine included. My pins, my holes were a little elongated when I first got the coach, and I've put about almost 60,000 on it now in 9 years, so it's held up great. And I've done a couple of other of these adapters, so we've got a lot of miles on them. They seem to work good. Again, I'll meet you over at the welding table and we'll weld these in. Okay, so the bushings pressed in. I've got a pin in there just to hold it for alignment purposes is all. And go ahead and run a bead around it. See if I can get around that without getting burnt here, but kind of get the idea there. Now I'll probably come back around and do a slight weave on it just to put a little more fillet in there. So I'll go ahead and flip it over and do the other side, and then I'll kind of decide whether I want to come back in with a weave with a cap weld. Alright, so I come in and I finish that off with a weave using the lay wire technique. I just laid the wire I bumped my amperage up just a little bit, about 15 amps I think it was, and come in, laid the wire in there, and then I took the torch and I just kind of weaved up, just kissing this top edge and then wetting the toe in at the bottom. So I just laid in there and I just capped. So I just weaved up and down and run a cap weld around that. So that just gives me a little more fillet, a little more support out in here without actually changing the inside there. So that's pretty much done. I'll throw a coat of paint on this, and yeah, I'll throw a coat of paint on all this, and it's ready for another hopefully 60,000 plus miles before I ever have to touch this again. Alright, thanks for watching. I hope this was informative, and welcome your comments. Thank you.